All right, so the next thing we're going to talk about is, remember, at the top of your page, you're going to write 1.2 order of operations. So you're going to want to write these notes down. So again, 1.2 order of operations. Next thing we'll look at is our goals for this lesson. Remember, you do not need to write down the goals. The goals are just to give you an idea of what we are going to be learning today in this lesson. So the first goal is we want to evaluate numerical expressions by using the order of operations. And the second goal is we want to evaluate algebraic expressions by using order of operations. So as you can see, the common theme here is order of operations. That's why the section is titled Order of Operations. So you should have 1.2 order of operations at the top of your page. So the first thing we're going to look at, and I do want you to write this down, this is a definition. You do need to understand what the word evaluate means. You will see this a lot this semester and beyond. So the word evaluate, it means to find its value. So if they ever tell you to evaluate something, just solve. You're finding the value of that question. So that leads us into, again, you should be writing that down. You should be writing down the next thing, evaluate numerical expressions. Example 1, and you should write this down. Evaluate expressions. So what are we doing here? We are going to evaluate 2 to the 6th power. What does this mean? So how are we going to evaluate this? We're first going to write it out. 2 to the 6th power means 2 times 2 times 2 times 2 times 2 times 2. It means we have 2 times itself 6 times. We have 6 2's, and they're being multiplied. So then we just go through and we actually solve this. We evaluate this. Well, our brains can only compute 2 numbers at a time. So let's do 2 times 2. 2 times 2 is 4. We can do these 2 times 2. These 2 times 2 are 4 as well. And we can do these 2 times 2, and these are 4 as well. We took 6 numbers, crunched them down to 3 numbers. Again, our brain does 2 numbers at a time, so we can do 4 times 4. 4 times 4 is 16. Still rewriting what we have not used. Now we got to do 16 times 4, and 16 times 4 is going to give us 64. So that's how we evaluate this expression here. Let's look at another one. 5 cubed, or 5 to the 3rd power. They both mean the same thing. So we have 5 times 5 times 5. Again, our brains only compute 2 numbers at a time. 5 times 5 is 25. We do 25 times 5, because again, we rewrite what we have not used yet. 25 times 5, well, this should be an easy one. How much money is 5 quarters? It is $1.25. So 5 times 25 is 125. All right. So this is how we evaluate an expression when we see these exponents. We write out what it means. 2 to the 6th power is 2 times itself 6 times. 5 cubed is 5 times itself 3 times. And then we solve. Here's one of those on your owns again. So remember, when we see these on your own, we already know we're evaluating this. So what I'd like you to do is I'd like you to pause this video, and I'd like you to try these 3 on your own. So you should be pausing your video now. So on your own, hopefully, for 2 to the 4th power, you got 16. For 4 to the 5th power, you got 1024. And for 7 to the 3rd power, or 7 cubed, you got 343. Hopefully you were able to get those. If not, hopefully you can look at these explanations, fix them in there so that you have more examples to look at. So the next thing we're going to talk about is order of operations. What is order of operations? Order of operations, this is a definition, is a rule to tell you which operation to perform first. And a lot of you guys may remember the saying PEMDAS, PEMDAS, whatever. So again, order of operations basically is a rule to tell you what to do first. So the first in the PEMDAS is a P. P stands for parentheses. You should be writing this down. So we always look to do something in parentheses first. E stands for exponents, meaning we perform the exponent second. So once all the parentheses are done, we now do anything in an exponent. The M stands for multiplication, and the D stands for division. The reason I said these together is these actually happen together, and you solve them left to right. So a lot of people have the misconception that you do multiplication first. No, you do multiplication and division at the same time. You just work left to right. And the last in PEMDAS is the A and the S. A stands for addition. S stands for subtraction. And these are just like multiplication and division. We perform them left to right. They happen at the same time. Addition does not come before subtraction. It is whatever you run into first, left to right. So PEMDAS, parentheses, so get rid of any parentheses first. E, exponents, get rid of all exponents second. Next, multiplication and division happen at the same time, left to right. Addition and subtraction happen last, left to right. So let's look at some examples. So let's solve this. 48 divided by 2 cubed times 3 plus 5. Well, let's run through PEMDAS. Are there any parentheses? There are no parentheses, so let's go to the next thing. Exponents. Are there any exponents? Yes, there is. There's 2 cubed. So we're going to rewrite whatever we do not use. So we have 4d8 divided by, well, 2 cubed. 2 to the third power is 2 times 2 is 4 times 2 is 8 times 3 plus 5. So again, I rewrote what I am not using at the time. Are there any exponents? No? Okay, good. Next, multiplication and division. Remember, we do these at the same time, left to right. We have multiplication, but we have division first. So that's why we will do division first. 48 divided by 8 is 6. So then we're going to rewrite times 3 plus 5. We rewrite what we don't use. All right. Is there any more multiplication division? Yes, there's a 6 times 3. 6 times 3 is 18 plus 5. 18 plus 5 is 23. Boom, we are done. As you can see, I ran through every time. In my head, what I did, I run through the order of operations every time. Now, when you solve these, you should see they make like a nice funnel. I like to say a pizza slice, where the original problem is your crust, and all the other math, those are your toppings. Those are your pepperonis, the sausage, the ham, the pineapples, the whatever you want on your pizza. Solving is these. So they make like a funnel. I like to call it a pizza slice. Some people like, oh, I like ice cream better. It looks like an ice cream cone, whatever. But when we solve these order of operations, we want to narrow it down and create that pizza slice. All right, let's look at another example. All right, this example, order of operation. Are there any parentheses? Yes, there are 2 sets of parentheses. So let's work on one at a time. Inside this first set of parentheses is 8 minus 3. 8 minus 3 is 5. So we're going to rewrite times 3. Well, this is where things kind of are cool. Because these parentheses are separate, we can do them also kind of at the same time. 3 plus 2 is 5. So we basically have 5 times 3 times 5. There are no exponents. Let's do multiplication division next. Multiplication division, multiplication, 5 times 3 is 15. Rewrite what we haven't used. 15 times 5 is going to give us 75. So that was another one. There we had parentheses, no exponents. There was addition, but it was inside the parentheses. And as you can see here, I still have my pizza slice. One more example. All right. So here, I'm going to hit extend page. So it's going to move it. Here, we have a crazy looking fraction. Don't think of it as a fraction. Think of this fraction bar as kind of a divider. It's two different problems almost. When we see something like this, we want to do the top, we do the bottom, and then we use the fraction bar. Okay. So you think of them almost as two different problems. So let's look at the numerator first, or the top part first. Are there any parentheses in the top? No. Are there any exponents? Yes, there's 2 to the 5th power. Well, 2 to the 5th power is going to be 32. So let's do minus, well, we can do 6 times 2, 12. We're going to draw our fraction bar. And now we're going to work on the bottom. Well, are there any parentheses? No. Exponents? Yeah, 3 to the 3rd power. 3 to the 3rd power is 27. Minus, well, you can do 5 times 3, 15. Minus 2. All right. There are no more multiplication, no division, just addition, subtraction. Remember, work as these as separate. 32 minus 12. 32 minus 12 is 20. 27 minus 15 is 12 minus 2 left over. 20 is already done. 12 minus 2 is 10. 20 divided by 10 is going to give us 5. And it's not 5, it is 2. Where I got 5 from, I have no clue. I wanted to make sure you were paying attention. It is actually 2. Okay. This is a funky looking pizza slice, but we still kind of are narrowing ourselves down. All right, so what I would like you to do is I would like you, so hopefully you have these written down. You have a bunch of examples. Now what I would like you to do is I'd like you to try these on your own. So what you should do is pause the recording now, pause the video now. I'm reading pause recording, good job. Pause the video now and try these problems on your own. So pause now. So hopefully you got 10 for the first one and 9 for the second one. If you did not, I'd like you to make sure you take a look at, see maybe where you made your mistake. If you're actually in person during class, we can talk about it as well. So take a look here, see if you did not get them correct, see where maybe you made your mistake. I went through and broke them all down. So 10 on the left, 9 on the right. All right, next, you're going to write this down. Evaluate an algebraic expression. Example 4, evaluate. So we have these algebraic expressions. So we got some variables. We're going to be using some substitution here. So we have 2 times the value x squared minus y plus z squared if x equals 4, y equals 3, z equals 2. So we need to first substitute. So we're going to rewrite this, and we're going to replace the variables with whatever value they represent. So x is 4, so it's going to be 4 squared minus y is 3, plus z squared. Z is 2, so it'd be 2 squared. Now I have a mathematical problem. I need to use my order of operations to solve. Parentheses first. Inside the parentheses, we have exponents, so 4 squared is 16. Hey, look, we have an exponent outside the parentheses. We can do this because it has nothing to do with the parentheses. 2 times 16 minus 3 is 13. Next, multiplication, 2 times 13, 26 plus 4. 26 plus 4 is 30. So again, we substitute. After we substitute, we then do order of operations. All right, so I want you to try this one on your own. So what I would like you to do is I would like you to pause this video and try it on your own. So please pause now. So hopefully you got 26. Substitute 4 in for D, substitute 3 in for F, substitute 12 in for G, solve using your order of operations. Boom, and you got 26. If you did not get 26, please try to make sure you copy this down so that you get the right pattern on here. Oops, sorry, hiccup. All right, so this is solving using order of operations. Hopefully it wasn't too long and didn't bore you too much. You were able to write them down. And now we're going to attack and solve a lot of this stuff.